validation and exceptions, fundamental to programming, as they are fundamental to life, okay? What do I mean by that? We validate everything we do. We validate it. Is it right? Is it true? Is it whatever? When there's exceptions to things, we have to deal with exceptions to the rules. So, when we're thinking of debugging, I say if debugging is the art of removing bugs from a program, then programming is the art of inserting bugs into the program. Interesting statement. Ponder that for a little bit. We need to validate user input, otherwise we're going to run into the problems. We need to make sure we don't get any of the ID 10T problems, okay? It's a unique error. All right, I told you enter an integer between 1 and 11. Why did you write David? Oops. Okay, so we need to validate user input, and you see that in a lot of apps these days, web apps, just apps on phones, apps on devices, all kinds of apps. You'll notice often it doesn't allow you to type in things, it gives you boxes to choose from, okay? Pick boxes, pick lists. Now, we say, is the input correct? We need to make sure. And by giving pick lists and things like that, it helps reduce the ID 10T errors that we get. So is the input correct? I say, is it actually correct? Can we check too many times? Are you sure the input is correct? You can see I've gone back again and again because we don't want the wrong input going in causing problems. Can you repeat that, please? Not all users get it right the first time, okay? So we need to be aware of that. Not all files actually exist. Let's open. Oh, that file doesn't exist. How do we open it if it doesn't exist? The file exists. Oh, you don't have access to it. Not all data files contain the correct data. I'm processing birth dates. Okay, 29th of September, 1855, 30th of October, 2022, 31st of February. What? So, not all data files contain the correct data. We need to be able to deal with these things. So, validating the input is crucial, and it can actually save lives. Here's a validation with an if statement. Number is assigned 0, enter a number between 1 and 6, get number. If number between 1 and 6, then the magic happens here. Run your code, else print input was not in the required range. We have now validated our input. A very simple validation process. The challenge is, of course, we can't go back in this situation. Yes. Okay, here's our Java code. Pretty straightforward Java code. We're now checking if number less than 7 and number greater than 0. All right, and we go ahead and do the stuff. Now, what about validating with a loop? We've already seen this when we were talking do while loops. Enter a number between 1 and 6, get number, magic happens here, well, number not between 1 and 6, and do while. All right, cool, that kind of works. And we run it here. Int number is assigned 0. Okay, so we've got a number that's valid. We get them to enter, or we've set, I shouldn't say it's valid, we set the variable to a number, we go into the loop, we ask them for a number, we check it, and we loop, or we don't loop. Pretty straightforward. What about exceptions? Now, an exception is exactly that. There's always an exception to the rule. Why is that? Because it doesn't follow the rule. That's why it's an exception, okay? It's usually something that was not meant to happen. That's why it's an exception, because it wasn't within the range of normal. Okay, so what are some exceptions? The user enters the wrong data type. The file doesn't exist. We divide by 0. Oops. When this happens, when this exception occurs, dealing with it is called exception handling. Now, what about Java and exceptions? Well, it deals with errors using exceptions. What happens is, when an error occurs, the program throws an exception. And if you think about it, when something is thrown, it generally needs to be caught. And that's how we will deal with it in Java. Okay? The program should catch the exception. Now, we say the calling method can catch the exception, and we'll talk about methods a little bit later in the course. Okay? Now, if the method that calls doesn't catch it, it's thrown to the next method up, and the next method, and the next. It just keeps going higher and higher. And if in the end the exception does not get caught, the program will crash. How do we go about catching them? Well, often it's all caught in one place in the calling method. Excuse me. Often we want to have it close to main, and some of this will make more sense when we cover methods, but we need to talk about it anyway. Now, it's very convenient to handle errors all in one place, all right? Now, most languages use this try, catch, and finally statements. So try defines a set of statements whose exceptions are going to be handled by the catch block. So we're going to do all these things, and if there's an exception that's thrown, we have a catch block that's going to catch it. And the catch block processes or does particular processing if an exception is thrown. All right? And the finally, well, the finally, that is processing that always gets done regardless of an exception or not. In Java, we use try and catch. So we have the try statement, and then we have the catch statement. And the catch has an exception and some kind of exception and code that occurs. So here's a Java program. Int number is assigned 0, scanner sc is assigned new, scanner system.in, system enter an integer. Great. All right. Now, sorry, that jumped a bit quickly. So the code makes sense. Let's now see what happens. We've got an exception message when there was an error that occurred that was preventable. So this code, I ran that previous code, enter an integer, and I wrote David. I'm a bright spark. And you'll see exception in thread main java.util.input mismatch exception. That kind of makes sense. We were looking for an integer, and we've got an input mismatch exception. That wasn't the input we were looking for. The program asked actually for an integer, but the user entered David, not an integer. Okay? So this input mismatch exception is what's thrown. The input mismatched with what we were expecting. An exception is thrown. Now, let's deal with this in an appropriate manner. And we've got now the try statement, and all that we're familiar with, that's in the try statement. And now we have this input mismatch exception, error, and the catch is it prints out something went wrong, error, system.out.print, the error. So what happens? Now, what we do is we can have a clean error message to the user that tells them what went wrong. The program doesn't crash, and we can exit gracefully or go back and repeat what we're trying to do. We might want to write it to a log file, who knows? But this is what happens, okay? Something went wrong, java.util.input mismatch exception, and then I say the error was. So I've repeated for the argument or for the example, the error message twice. But now you'll notice there's not this dump of everything that's gone wrong. We've just exited our program very gracefully and easily now fixable. Or we could have gone back. If you think of one of the constructs, if we had a input mismatch error like we've had here, we could go back and ask, would you like to do that again? Arrays and exceptions, okay? So arrays are of fixed length. We've seen that before, okay? In Java, memory outside of the array can't be accessed. So if we look at this code here, and I've gone, the array 101 is invalid. So down in this line of code, what I've tried to do is I've tried to access 101, but there's only 100 spots. Alright, we're going to have an exception thrown. And when we have an exception thrown in, or with arrays, I should say, what happens is we get this error message here, exception in thread main Java, array index out of bounds. Okay, array index out of bounds. The array has 100 elements and I've attempted to access 101. The array index out of bounds exception. Now here is our Java code. So what are we doing? We've created arrays. Here we're initializing, we're putting values into the array. Okay, as we saw when we were working with arrays, we've now put values into them. All right, we're now printing them out or doing some fun things, but this one here that I have successfully covered up is going to create our error. But by handling it with this, we're going to exit our code very gracefully. So exception handling is really important so that our code executes cleanly, it exits cleanly, and the users know what's going